Hello everyone, this is Dr. J. Today I'm going to talk about some private school scholarship entrance test for mathematical problem solving. Today we're going to continue on spatial reasoning of mathematical problem solving. Here we go. This is simple like one sentence question. How many shortest paths are there from Sydney to Brisbane? And this diagram is attached to this problem. It is a rectangle 5 by 5 and the internal one 3 by 3. And you can only going through these black lines from Sydney to Brisbane. And the note saying the shortest path means the movement can only be going from left to right and from up to down. So simply you can see from Sydney going 5 steps to the right hand side and 5 steps down to Brisbane. So the shortest path would be 10, but you can also from Sydney like one step right hand side and one step down and 3 steps right hand side, three steps down and one right, one down, something like that. There is many choice, but the question is how many different choice. You could take a few minutes to think about it. We're going to cover the solution shortly. Before we release the final result, I would like everyone to learn some foundation knowledge from this page. Have anyone heard about or seen this triangle before? Yes, it's called Pascal triangle or Yanghui triangle in China. Pascal is a French guy, and he's not just a mathematician, and he's also a philosopher and inventor. Yanghui was born 400 years at least, before Pascal to identify these geometry arrangement of binomial coefficients in a triangle way. However, Pascal is the first Western guy to have theorized this number pattern. And for this problem, the shortest path will definitely follow these like a number pattern. We can learn each node here, right, like 3 here, their value is the sum of the value, 2 nodes value from above. 1 plus 2 is 3. Another example, if you look at the node 10 here, its value 6 plus 4, right? So this is a way we extend the Pascal triangle to further layer downwards. And look at these diamond, you can push that, to a rectangle. And if Sydney was based here, Brisbane was based here, and you want drive from Sydney to Brisbane through these towns in between, how many ways? For example, this question, similar to what we try to resolve here. The answer is easy, 20. Just adding them together, adding those not value together, you get it. So it's actually quick. With this foundation knowledge, you should be able to resolve the problem in front of us quickly. Also, I would say something, extra as an extension of this math question. These number pattern can be used or called as binary tree structure, which is very useful. You also learn some digital technologies, and in the digital system, like a computer, we use binary, and in our math mostly we use decimal, right? But the binary tree is used frequently in the computer science area is a tree data structure in which each node has at most 2 children, referring to as the left children and the right children. This structure is commonly used in various algorithm and data storage memories and data processing as well. So your CPU, your RAM, your hard drive are all using binary to get your data storage and processing. I hope my students all become well-rounded talent rather than just memory, knowledge points by rote. Like, you don't want people call you geeks. That's why in Dr. J's class, you can learn lots of knowledge like history, geometry and science, digital technology, computer science. They are connected together, and you not just mainly learn mathematical knowledge, you know how to use that, its future application. It's quite vital to your future journey, I think. Here we go. Final solution page. The final solution of this problem will turn out to be very straightforward, I promise. Based on the background knowledge we have learned in the previous slide, go back to the original question. From Sydney to Brisbane, how many different patterns or road as the shortest path? The tricky thing, it's not a full matrix. It's actually empty here. It's like a square-shaped donut, right? And I just use Pascal triangle with Sydney as the first node here, going to this way, I get the result 52. But when those boys and girls work on this, they still make some mistakes. Let's focus on those careless mistakes they have been taken. For example, here, 2 green circles. Some kids, they didn't know what the number need to put into these 2 green circles. Let me ask another question. There is 3 towns. From town A to B, there are 5 choices. And from town B to town C, there are 3 choices. How many choices from town A to C? Yes, easy, right? 15. You just need to multiply these 2 numbers together. Like 5 multiplied 3 is 15. Here, let's back to the map. Sydney is A, and B is this town. When we go to C, from Sydney to C, to A to C, there is 5 choices from A to B. Here, how many choices from B to C? There is only 1, right? So, back to this question. The result is 5. 5 by 1 is 5. Just multiply them together. And if you regard the town C as an airport, a traffic center, there is only 1 arriving path. and 2 departure paths. Don't care about departure paths. Yeah, just cut the light green one, you know, focus on the dark green or the blue. Yeah. On the arriving path, there is only one choice. So you just copy the number from town B to this node, town C, and that's it. And this diagram is symmetric, so same-wise for this town is 5. Right? There is another careless mistake. From the red circle, some boys just put another 5 here, but actually same way. If you think about this airport, the arriving path, there is 2. Different with town C here, there is only 1 input. There is 2 input as arrival, so you have to put them together. So 5 plus 5, 10, right? So the final result will be, 26 by 26. That's 52. This is just doing math, adding numbers together, simple like that. I can do that in like 1 minute. I'm not sure how many minutes you spend without learning those foundation knowledge, without the lesson you have learned here today. You won't be able to get the right answer in a very short amount of time, right? And a quick summary. So we need to learn how to apply our basic knowledge to solve complicated or complex problems in a flexible way. Okay? You have to think about how to apply that and do more practice. So focus on your homework today. Also, try to expand your mathematical knowledge to some other area, like digital technology, computer science, or your game, everything based on mathematics. So you will definitely find your motivation. This will be very helpful to your interests and to your passion on math learning efforts. So it will be also have positive impact for your life and future work, right? And I hope you all enjoy lesson we learned today, and have a good afternoon.